Hello children, hope all of you are doing fine. Last class we have studied about determinants and how to find the values we have studied. Today also you will evaluate the determinants by using properties. Today's topic, evaluation of determinants by using properties. Today you are going to study some properties by which you can evaluate the determinants in an easier way. So that is the use of properties, so that you can evaluate determinants in an easier way. So there are so many properties. Number one property is that the value of the determinant remains same if its rows and columns are interchanged. So for determinant I am using one symbol of delta, triangular symbol. It is called delta for determinant. And you know that determinant means always 3 by 3 order determinant, or 2 by 2 order means always square determinant. So here I am taking one determinant whose row wise I am telling A1, A2, A3, B1, B2, B3, C1, C2, C3. Now if you interchange the rows into columns and columns into rows, then also the value of this determinant will remain same. Suppose rows and columns are interchanged, then this row first will become your first column and second row will become your second column, third will become your third column. So in this situation also the value of this determinant and then the value of this determinant both will remain same. That's why equal sign is there. So this is the first property of evaluating determinant. So when you interchange the rows into columns and columns into rows, then the values of the determinants will remain same. Our second property. Very carefully learn these properties, okay, very important. And also every year one question is coming based on determinant, and where you have to evaluate the determinant or you have to prove something based on determinant, and you have to do everything by using these properties. So you learn the properties very carefully. So hope you have understood the property number one. That is very easy and very simple. Now second property is that if any two rows or columns are interchanged, then the sign of determinant changes. Sign of determinant means plus will become minus and minus will become plus. So suppose this determinant value is a positive value. If this is giving a positive value, now in this determinant, if you interchange any two rows if you interchange, or any columns, if you interchange any two columns here in this determinant, then the value of the determinant, numerically value will remain same, but the plus will become minus and minus will become plus. Suppose the value of this determinant is 5. So if you interchange any two rows or any two columns, then the value of the determinant will be your minus 5. So you see here I am interchanging, suppose row 1 and row 3 I am interchanging, then if here determinant is positive determinant, then here it will be minus. So suppose row 1 and row 1 and row 3 interchange, the row 3 is coming in place of row 1, C1, C2, C3, and row 2 will remain as it is, and here row 1 will go to the row 3. So this is the property. Here what property I have used? Row 1 interchanging with row 3. So this property you have to mention in the side, right hand side. So if you interchange in two rows or any two columns, then the sign of the value of the determinant will be changed. So plus will become minus. If it is minus, then it will be your plus. This is also this is the property number 2. Next we go to property number 3. If you have doubt, you can repeat the video and try to understand it carefully. Number 3 is if any two rows or columns of any determinant are same, then the value of the determinant is 0. Here you see, in the determinant, row 1 elements and row 3 elements are same. So if the elements of any two rows or if the elements in any two columns are same, identical, then the value of the determinant will be equal to 0. This is the property number 3. So understood? I think these 3 are very simple. Next, altogether there are 6 properties. And next I'll move to the property number 4. Property number 4 is that if each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. So if each element of any row or any column of a determinant is multiplied by a constant k, then the whole determinant, value of the whole determinant will be multiplied by the constant k. Okay, I'll explain this in an easier way with the help of one example. Take one determinant. Suppose the first element are multiplied by the constant k, ka1, ka2, ka3. First row elements are multiplied by the constant k, and second row, third row will remain b1, b2, b3, then c1, c2, c3. So I am explaining the property in an easier way so that you can understand it easily and I can apply in solving the problems also. So here you see the determinants. First row elements are multiplied by a constant k. Then you can take k as a common factor. So common factor will come outside. So I am taking common factor from the row 1. So row 1 will be your a1, a2, a3, and b1, b2, b3, and c1, c2, c3. So inside a bracket you write, taking k common from row 1. So in determinant you can take common from any single row or from any single column, but in matrices what you did, when you take common in matrix, you have to take common from each and every element in matrix. But in determinant it is not like that. In determinant you can take common from any single row or from any single column. So this is the way of taking common from determinant. So this is the difference between matrix and determinant in taking common factor. Okay. This is your property number 4. One more thing I am showing here. Suppose one extra determinant A, B, C, D. I am showing you 2 by 2 determinant, and name of the determinant is delta 1. And suppose you are going to multiply the row 1 by constant k. So how will do this? In arithmetic, here you see, suppose number 5, so write equal. If you multiply 5 by 2 and we are putting an equal sign, is it possible? Not possible, because 5 and 8 it will become 10. 5 and 10 not equal. So to maintain the balance, if you are multiplying by 2, then immediately you have to divide by 2 to maintain the balance. So here also, if you are going to multiply the elements of row 1 then by k, so you write the row 1 elements as ka, KB, and row 2 elements will be CD. But to maintain the balance, outside you have to put 1. Outside you have to multiply the determinant by 1 by K. So also you remember, in matrix, when you multiply, you have to multiply each and every element of the whole matrix. But in determinant it is not like that. In determinant, if you are going to multiply by any constant, then you have to multiply, you are allowed to multiply only the elements of any single row, or you have to multiply the elements of any single column. So this is the difference between matrix and determinant in case of multiplication. So this point also very important. These points you remember, very important points. These points will be frequently applied when solving the problems. Okay, if not understanding, you repeat the videos 2 times, 3 times, pause the videos and try to understand carefully. So I have explained the property number 4 in an easier way. Now property number 5. Property number 5 says that if sum or all elements of a row or column of a determinant are expressed as a sum of 2 or more terms, then the determinant can be expressed, or you can break the determinant as a sum of 2 or more determinants. So here it is, if sum of, here sum of, if sum of all elements of a row or column of a determinant are expressed now it will be or only, I am correcting here. Okay, if sum or all elements of a row or column of a determinant are expressed as a sum of 2 or more terms, then the determinant can be expressed, or you can break the determinant as a sum of 2 or more determinants. So here you see, you concentrate on the elements of the row 1. Row 1 elements, you see they are the expressions having 2 terms. See the elements of the row 1, or each and every element in the row 1 are containing 2 terms as a sum of 2 terms. So based on the row 1, you can break the whole determinant into 2 parts. In one part, the first term of each element in the first row will be used. As the elements of the first row are the sum of 2 terms, so when you break it, you have to break into 2 determinants, because the elements in the first row or the terms are having 2 terms. So in the first determinant you have to use the first terms, and in the second determinant you have to use the second terms in the first row. The remaining second row and third row remain as it is. Now see how I am writing here. First determinant. In the first determinant, row 1 elements will be your first term of each element. A1, A2, A3, and row 2, row 3 will remain as it is. So this is the first determinant, and second determinant will be the second determinant. First row elements will be second terms of each element of the first row. That means lambda 1, lambda 2, lambda 3. Then second row, third row as it is. So this concept of breaking determinants is applicable based on any rows or based on any columns, if there you find the elements as a sum of 2 or more terms. Okay, so this is the property number 5. So the last property, now study the last property, that is property number 6. Property number 6 says that if to each element of any row or column we add the corresponding elements of any other row or column multiplied by a non-zero constant, then the value of the determinant remains same. So like this property you have got in matrix also. So same property here also you are getting. So if to each element of any row or column we add the corresponding elements of any other row or column multiplied by non-zero constant, then the value of the determinant remains same. So for example, here one determinant is given. Now what I'll do, I'll change the elements of row 1. You can do with any elements of any row or column. I am choosing the row 1. Now I'll change the elements of the row 1. How I'll change the elements of row 1? By adding the corresponding elements of the row 2, and also by multiplying the elements of row 2 by a constant, and then adding the corresponding elements of row 1, and in that way I am going to change the elements of row 1. So how will you show the operation? Say here you write R1 will be changed. How R1 will be changed? As R1 will be changed as R1 plus, then adding the corresponding elements of the row 2 by multiplying the non-zero constant, say k is in R2. Then you see what will happen, and in that applying this operation also the value of the determinant will remain same. So I am continuing the equal sign here and write the determinant. Now if you apply this operation in the first row, the first row elements will be a1 plus k b1, and second elements will be a2 plus k b2, third element will be a3 plus k b3, and second row third row will be as it is c1 c2 c3. So I am combining two rows and changing the elements of row 1. So it is not restricted only with the 2 rows or 2 columns. You can extend this operation up to 3 rows or up to 3 columns also to make change any row or column. Okay, we can add 3 rows also, elements of 3 rows or 3 columns also to make the change in any row or column. So see, it is not restricted only for 2 rows or 2 columns. Okay, this is the property number 6. So as per the textbook we have finished the properties. Now one more important extra property I am giving you. The extra property is that if each element of a row or column are 0, if each element of a row or column are 0, then the determinant becomes 0. So here you see in this determinant a1 a2 a3, then second row all elements are 0, and third elements you see c1 c2 c3. So here as all the elements of the second are 0, so the value of the determinant will become here 0. So this is also important property. So you have learned the properties. First you repeat the video and learn again the properties one by one. Try to understand this, and then you solve the problems. Now we'll go to the exercise. So here exercise 4.2. So in this exercise some questions are given, you have to prove it. So question number 1, determinant is given and you have to prove that the determinant is equal to 0 by using properties without expanding. First you apply the properties, and if it is required at the end you can expand the determinant, but in the beginning don't try to expand this determinant and prove equal to 0. So you are asked to apply the properties and prove it equal to 0. So always try to apply the properties. So first I will use this left hand side. Left hand side it is x plus a, y b, y plus b, z c, z plus c. Now see here the third column elements. Each element, the elements are the sum of two terms. The third column elements, there are sum of two terms, so we can break this determinant into parts based on the column 3 elements. So first column will be your x, y, z, second column will be a, b, c, and third column will be your x, y, z. This is your first determinant, plus second determinant will be your first column x, y, z, second column a, b, c, and third column will be the second terms of the third column a, b, c. So after breaking the determinant based on the column elements of the column number 3, you see the first part, you see first column and third column same. So here column 1, column 3 both are identical same, so here value will be 0 as per the property. And here also in the second determinant, you see second column and third column, they both are identical same, so here also value is 0. This is equal to 0, that is equal to right hand side. Now question number 2, this you have to prove equal to 0. Start left hand side. It is a minus b, b minus c, c minus a, b minus c, c minus a minus b, c minus a minus b, b minus c. Now what I'll do, I'll add all the elements of all the 3 rows. I'll make a change in the row 1. The row 1 elements will be changed. How the row 1 elements will be changed? By adding all the corresponding elements of all the 3 rows, R1 plus R2, R3. Now see, if you add, what will happen in the row 1 elements? You see, now check what will be there. If we add all the 3 rows elements, corresponding elements of the 3 rows, okay. First you add the first elements of all the 3 rows. All these 3 elements you add. What will happen? If you add, then plus a minus a will be cancelled, minus b plus b will be cancelled, minus a plus c will be cancelled. Then your first row will be 0. Second element of the first row, add all these 3 elements. Now when you add all these 3 elements, then what will happen? Plus b will be minus b cancel, minus c plus c cancel, minus a plus c cancel. So here 0, first row. And third element of the first row, here also it will be 0. So this change you will see after applying this operation. And row 2 will remain as it is. Row 3 will remain as it is. Now see, as all the 3 elements are coming 0 of the first row, so this will become here 0. This is your right hand side. Now question number 3. See it carefully. It is 2, 7, 65, 3, 8, 75, 5, 9, 86. So now third column elements are all the larger elements. So what you'll do, you have to break the elements of the third column. So how will break? Now first you think about 65. So you have to divide 65 by this 7. And after dividing, you must see that remainder must come here 2. The smallest numbers of the column 1 must be the remainders. So if you think about 65 divided by 7, so how many times it will go? So changes will happen in the column 3. So first column will remain as it is. Now third column you write using dividend divisor quotient format. Now if you divide the 65 by 7, it will go how many times? 7 into 9 7 9 63 plus remainder 2. The first column elements must come as remainder, and I will divide by these second column elements. Now comes what, 75 divided by 8. The 8 into how many times? 9 times 8 9 72 plus 3 remainder. This 3 is coming remainder now 86. So 9 9 86, 9 9 81 plus 5. This 5 is coming as remainder here. Okay, this is coming. Now see here, third column elements are the sum of two terms. So based on the third column elements, you break this determinant into two parts. So I'll show here. First column will be 2, 3, 5, 7, 8, 9. Then here third column elements will be your first term in the first determinant. So 7 into 9, 8 into 9, 9 into 9 plus the second determinant. First column as it is, second column as it is, third column with the second terms of the third column elements. So 2 3 5, 2 3 5. So this determinant is separated in two parts. In the second part you see first column and third column same, so here value will be 0. Now I told you that in determinant you can take common factor, and when you take common factor in determinant, you can choose any one single row or you can choose any single column to take common factor in determinant. So here I can choose the third column to take the common factor. So from this column 3, I will take 9 as common factor. So 9 is taken common factor from the column 3, and first column as it is, second column as it is, third column will be your 7, 8, 9. And plus this is your 0. After taking 9 common from the third column, see that second column and third column are coming identical, same. So this into 0 plus 0, so ultimately it will be your 0. So it is your right hand side. So 3 sums I have done. So I'll give some extra sums and apply the properties and solve it, and the remaining sums of the exercise I'll do in the next class. So thank you very much. Hope all of you have understood. Okay, till then, bye bye.